Hi, everyone. Thanks for joining. I'm Jared Carfentan with Sente, and thanks for joining our first Sente Startup Garage of 2022. Happy New Year and welcome. And we will be talking about, we've got three of our startups from the Sente family in the area of low-code, no-code tools for industrial applications. And well, before we kick it off with the startups, Yasemin and I will be sharing some information from the market research that we've been doing in this area, and then we'll hand it over to the startups to do their to show what they've got. So let me share my screen. Oh, I need to allow my system preferences, just a sec. Let's see if this works. Yasmin, can you confirm that you can see my screen? Okay, excellent. Well, thanks everyone for joining. Apologies for the slight security issue with my Mac to allow me to share my screen. So just real quick, I'm Jared Carfentan with Sente, the COO. And just to introduce ourselves for those of you that may not know us, and we work with early stage startups and large international corporations, and we like to bridge the gap between those startups and the companies and bridge it in between the accelerator stage and seed and Series A stage. The programs that we run help with customer validation, connecting with product market fit, help the startups when working with our corporate partners and investor partners with the go-to-market strategy and technology development. So we help those startups kind of take it to the next step and get to the point where they can raise significant seed and Series A investment and on their path to scaling up. With that, I'm going to hand it over to Yasemin Avci from our analyst team, and she's going to share some information we have on this market.
Actually, I think we just skipped a slide.
There we go. Sorry.
Yeah, thank you. So low-code, no-code are visual development environments that allow enterprise developers and citizen developers to implement complex workflows, logic, and integration using drag and drop and wizards rather than writing lines of code. The difference between low-code and no-code is low-code platforms are generally aimed at developers who have technical knowledge and help these skilled people work faster, whereas no-code platforms target business users without the need of certain skills. The worldwide low-code development technologies market was projected to total $13.8 billion in 2021, with an increase of 22.6% from 2020. To be specific, the surge in remote development during the pandemic is expected to boost low-code adoption, despite ongoing cost optimization efforts. Regarding many workplaces in Turkey and Europe returning to online again this month, increases the likelihood of this trend through 2022. And up until now, low-code application platforms were the largest component of the low-code development technology market. And I believe it's likely to stay that way through 2022. What low-code offers is application prototype within minutes, reduced dependency on specialist developers, common platform for domain experts and developers, and leverage of APIs to enable faster integration between IT systems and between business partners. Additionally, domain experts can focus more on delivering solutions than learning to code. However, just like many technologies, low-code comes with challenges as well, such as difficulty in auditing and inspection, lack of customization, creating lock-in, which makes it difficult to leave the provider. And another setback is scaling compared to traditional platforms. Can we move on to the next one, please? Okay, so here's our view of the world of low-code platforms. We define it in 4 categories. Of course, there's a lot of overlap between categories, and the platforms are evolving in different ways. So the first one is productivity workflow automation. These are tools like Zapier, which are positioned primarily to individual users and teams to be able to integrate multiple internet tools and make them more productive. The second category is enterprise workflow automation, which has platforms that are used by companies to automate and provide more control over their business processes. One way you can tell the difference between the two is whether they show their price on their website. So today, they're mainly used for processes in IT, human resources, and finance. Low-code web app platforms are tools that are built primarily for building a fully functional user interface, a front end, rather than automate a workflow. Although they have like workflow automation capabilities, these tools are best to use to quickly stand up a fully functional web application or mobile application that uses data. And the last one is industrial low-code platforms. These are low-code tools that are useful for what we call industrial problems, dealing with things like machines, manufacturing processes, supply chains, and blue-collar workers. So this is an emerging category because the data and processes are not as open or standardized, and the implication of failure are high. This is also where there's a lot of new opportunity for startups like Netloom, Stroma, and Astracode. Yeah, so I'll handle it back to Jared to continue with investment trends.
Thanks, Yasemin. Yeah, I think if we look at the evolution from the low code being more for business applications, now we're seeing it more for industrial applications. On the investment trends, that most of the investment happening in this space right now is has been in the United States, as you can see. Now, this is one of those things that as the rest of the world kind of catches up in the prioritization of low code, we would expect more and more investment to happen outside the United States, like with everything else in the startup world. What was interesting in the funding by year is that there was a wave in 2018, major funding happening in the low code space, and then picking up again in 2020 and 2021. My hypothesis on this is that the money was going 3 years ago was going more towards those 2 categories on the left that Yasemin showed before, which was more for kind of business type of workflow tools, and we're seeing more funding going towards low code in more use case specific and industrial kinds of areas. This last one, the lower right, the number of companies by stage, is not to scale, as you can see. There are a lot of companies entering the market. So the way to read this is just to see just how many new companies there are that aren't funded yet in this space. So it's really exciting in the early stage, like pre-seed area where we like to play as Sente. Very few exits, relatively speaking. So really is very much an emerging space. And I understand something is there's an issue with my voice quality. I'm not sure this is rare for this microphone. It's normally okay. But the good news is I don't need to speak anymore, and we can hand it over to Jan from Netloom. So the three startups that we'll be presenting today are using no code and low code approaches to solve 3 different areas of industry problems. Netloom around industrial IoT and industrial digital twins, Astracode in the blockchain space, and then Stroma using computer vision for workplace safety. Apologize for the quality of my microphone, but I'll stop sharing, and then Jan can introduce Netloom and do your demo.
Thanks, Jared. So I'll share my screen. Give me 1 second. Should see the presentation, right?
Yeah.
Awesome. So we started off initially as a analytics company for big data projects with big industrial clients, mainly utilities, water, electricity, these kind of things, and have then been involving in integrating the concept of digital twins into the whole process more and more, and have developed a platform that runs in the background to handle data aggregation from various sources and analytics integration as a platform, as a technology tool that mainly works in the background. In that process, we have seen that this is still a really big issue in the space. Almost all projects flat out fail. The same true for big data as for IoT. And if you want to really get value out of IoT, you won't get around analytics, big data, AI, right? Because you have a tremendous amount of data points and you want to make sense of them. So if you go through these failure rates, I don't want to bore you with the exact math, but you end up in staggering amounts of money spent without actually creating value. And a big part of that is that things are too slow, they are too costly, it's hard to prove actual impact on your business. So what we also figured out is not only streamlining it in the background, but also enabling people that might not be that familiar with development, like engineers, to bring in their value and their knowledge into the platform easier and easier is a really big task. And we have been moving more and more into the low code and no code space over the last, particularly this year, due to various projects we've been seeing NetLoom used in the past. So in essence, what NetLoom is, it's a low code environment, more and more so. It's a moving process, right? It's completely domain agnostic. We are focusing on electricity, utilities, water utilities, these kind of players, but it could be used for railways, as you will see later. It could be used for all kinds of industrial networks, really, where a digital twin will bring value. And due to the low-code approach and a lot of automation that it brings, it's super fast. You really quickly can see results. This is basically the number of USPs, the structure that NetLoom is working in that middleware approach. And we really bring basically these aspects of AI, of digital twins, wrapped in a low-code environment to the play. And therefore, we are much faster in terms of figuring things out, doing rapid prototyping, and deploying the solutions that you are building. Let's jump in the demo. For that, I'm not sure I shared the screen. Let me check. Let me make sure I shared the whole screen. Something's wrong here. Give me a second. So, no, that is wrong.
We see your whole screen, by the way, yeah.
You see it? Awesome. Thank you. So this is NetLoom. This is the first page of NetLoom. I'm playing around with two instances here. This is really the cutting edge version because I want to show you the latest and greatest. If there might be an issue, I might switch to another one that is a stable version of the software. If you want to create a digital twin of anything, you need to understand the domain you're playing in. And this is something that can cause a challenge to formulate in a streamlined fashion. In the background, there are things like graph databases, triple stores, semantics, all these kind of buzzwords that a data scientist will understand and can work with, but an engineer probably never heard of. What we created for this is a very easy tool to generate these kind of structures in a drag and drop environment. And there we go. Give me 1 second. There. Let me try one more time. Yeah, there we go. So you have various assets in that you want to use in your digital twin to model the whole network. You have probably, this is a train network, for example. You will have hundreds, thousands of trains in the field. You will have the railroads. You will have various sensors. This is obviously a very small sample of this. You can go in more and more detail in that regard. If you look at a train, for example, this is a very simple model of a train. but it's easy to understand. You have a train, there are some sensors, and there are last but not least data points. These data points you can connect with databases that you can put in the background into our systems. It can connect to all kinds of systems. Each one can connect to a different kind of database, so you can really get access various data sources here, bring them together and have them available to build your applications in a very easy fashion. Right now, building these connectors still needs a bit of code. Also there, we will move more and more into a low-code environment where you can use the user interface to access those databases. Last but not least, you have that information here, and you know exactly, due to this, what it maps to into the information to the databases that you already possess. This Netlum uses to create an automated generation of a digital twin. What that means, I can show you here. You might have seen that we have two domain models here. One is for this railroad network, which I can show you in a moment. But there are also connectors and the domain model for electric grid in the background. Right now, here is no digital twin of an electric grid. The system doesn't have any information about any electric grid out there. It just knows where the database is and what assets it has to link to visualize the digital twin here. So with that knowledge, we can create from 0 to thousands of assets in a digital twin. We can do that in a few seconds. So basically what you're seeing here is really a real-time generation of the digital twin in the background. And there it is. We can open it. It might take a moment to load. There are quite a few assets in there. And already you have the digital twin of electric grid of a city of a few million people, including various meters, thousands of meters in here, or hundreds of meters. I'm not familiar with the exact numbers of this one, but quite a few. And kilometers and miles over miles and kilometers over kilometers, depending on what you're using of electric grid. And this is ready to be manipulated and to work with. It's directly available in a streamlined API on which you can build your applications, potentially also in a low-code environment. And the same is true for every new city that you want to generate here. If you do the same mapping for the next city, your applications will find the same data points under the same interface in the digital twin of that city. So the application that you build for city 1 will work the same way for city 2, where the data originally is stored in very different systems from a very different company, different client of yours, and so on and so forth. So if I wanted to, I could go ahead and generate something like a heat map based on this visualization tool, all this based on that same API that you have available to build your applications on top, and say, okay, I want to see how old are the updates of the firmware of the meters, and I will get a heat map of that data point directly, automatically generated in the digital twin. I could look at analytics here and see if there are, but I think it's not in this instance. Let me quickly switch to the other one there. I'm sure I'll have it. Yeah. So that's the stable version where I know we have the data. Here you also see we have a heat map, which is quite interesting, of the grid line, by the length of the grid. So you see all the red lines are long grid lines supporting the city, where it then goes into smaller ones which support the houses there. You can attach all kinds of analytics as a data scientist here. Maybe an example. And again, all this information, there's nothing in here. But all this information that you see here is available via API, and you can use it in your application that you build on top. Let me quickly go to this one because I still want to show you the railroad digital twin as a comparison. If it does what it's supposed to do. Okay, let me refresh this. It's still the wrong one. That's still the electric grid. My apologies. As I said, this is a development environment. Would really like to show you this one because we actually have moving trains in there. That's a new feature. But if it doesn't work, you've seen how the digital twin works. The real effect that we have here is that you can generate it extremely fast and the data becomes available pretty much instantly. Okay, I think I will cut this here. This won't work. There we go to the other instance. What we will add in the next step in terms of low-code and no-code environments is, as I mentioned earlier, creating connectors, as you've seen in the environment for the domain model, and a system to define analytics, because in this system you also are able to stack analytics on top of each other. So once you have analyzed a certain information point, you can add this as a component. It becomes available again in the system, and you can then compute this pre-computed information once again. And this is something you can very nicely fit into a low-code approach. And this is something that will come out in this quarter of 2022. And basically, that's the system as it is right now. So from my side, I think you're good. If there are any questions directly, we'll have a Q&A later. So I'm looking forward to that, and happy to hand over to the next team.
Damiano, thanks, Jan. And anyone that has any questions, you can also use the Q&A panel anytime, and the founders may choose to answer those questions at the time or wait till the end. So, Damiano, you're up next.
All right. Hello, everybody. Can you hear me?
Yes.
All right. Perfect. Let me share my screen real quick. All right. So so first of all, thanks everybody for attending, and thanks Jan for a nice presentation so far. I'm here to present AstraCode, which is basically a company that aims to facilitate enterprise blockchain development. Now, the interesting part here is that this is a very new space. So as Jared mentioned, it is in general the low-code space, and in particular the let's say enterprise low-code space is kind of a new space. But here we're dealing with kind of a meeting within two new spaces, because one is the enterprise blockchain space, and the second one is the actual enterprise low-code solution. So what we're trying to do here is to solve the problem of implementing an enterprise blockchain solution. Now, what is the problem? Of course, there are different types of enterprise blockchain solutions. In general, enterprise solutions can vary a lot, but you're stuck mostly with couple technologies, since the developments in this space are relatively new. So for instance, Hyperledger Fabric is usually the technology that's most utilized. And we started actually by developing some Fabric projects ourselves, and we realized that the development was very, very hard. There aren't a lot of resources available, and the stack is quite wide and tall as well. And in general, this is actually something that when we looked into, we looked around us and asked around be it to other companies or developers, we found that they also felt the same way. So we thought, okay, we have an expertise in low-code solutions. What can we do to help them out? What we came up with is basically a solution where you can you have low-code environments that help you out in every step of the development cycle for the enterprise solution. So let's say you have this idea, I want to have a blockchain network for, let's say, I need to notarize documents on the blockchain. And I want to do it in my own network because I don't trust the public network, or maybe I want to keep control or whatever. So what I need to do, of course, in the first place is have the network. And then on top of the network, you're going to have to deploy some smart contracts, which will provide the backend for whatever application you're trying to build. So the solution, at the moment, we only have the network composer, as I will show you also in the roadmap, but it's comprised by the two main development environments are the network composer, which is for a blockchain network, and the smart contracts IDE, which is, of course, for the smart contracts. But then also the solution typically will need to be deployed on cloud. So we also provide assisted cloud deployment. And of course, we also have the possibility to customize your deployment. So if you want to deploy it locally, maybe you don't have a cloud, maybe you don't want to use a cloud, you're also going to be able to do that. And this is basically kind of what it looks like. It's very simple. In 3 steps, you're able to design whatever you need to be designing, be it the network, be it the logic. What we have so far is the network composer with the network generation, which I will show to you in a moment. What's coming up in the first couple quarters of this year are the first set of premium functionalities and the smart contracts IDE, which will be, of course, a game changer because any solution will be incomplete just with the network. So let me show you what this looks like. I kind of already prepared a bit of something here. So basically, this is the interface of the network composer. Here you can basically navigate whatever projects you have. You can, if you have more than one project open, you can navigate like from one to the other. And you have, of course, some general shortcuts for like undo, redo, this kind of stuff. In general, what this is thought for enterprise blockchain networks. And in general, what the assumption that you have there is that you have organizations that need to transact with one another. So the way that Hyperledger Fabric works is that you actually have to create new organizations and then set them up so that they can transact with one another. So far, I created an order organization, which is basically the infrastructural, kind of like the governance of the whole network. It handles the transaction ordering, and basically, in general, it's thought of as kind of an independent entity. And then I have Astra Code and Acme, which are basically two dummy enterprise, like say, client organizations. So here you see when you define an organization, you only have to define the name, the type of organization, if it's a client or an order organization. And then you can define 1 or 2 CAs, which are basically they are the entities that provide certificates for that organization. Because of course, in order for the network to be secure, any participant will need a type of certificate that will be, let's say, will provide them with credentials to log in and operate on the network. So in general, what I wanted to demo here was a simple use case for document notarization. So the idea is that maybe you have a document that you want to notarize for whatever reason. Maybe you want to make sure that it is not tampered with. Maybe you want to do it for to store it for a longer period of time. And in general, for this network, it's a very simple setup. So you have a channel, which is a subnet where different entities operate, and you're going to have just one channel with the 2 organizations, and each of them will have a peer on the channel. So I'm just gonna define real quick this is a consortium. Basically, a consortium is kind of like a theoretical implementation of a channel. You will put together the organizations that need to transact with one another, so that once you implement a channel for the consortium, you can isolate communication, and you can only have the information that's on the ledger be accessed by whatever organization is part of the channel. So this is the channel, and very easily you can add the different components. Here you can add, for instance, peer. It's for the network, you can only add a peer or ordering service because everything else is automated. So what I'm going to do here is just add a single peer for each organization. A peer, of course, is what allows an organization to actually interface with the network, and also it will host a copy of the ledger, so that an organization will always have their own copy of the ledger. So if there are any conflicts, they can rely on that. So here you can define the owner. There is everything runs on a Docker container, so you have to define the ports on which the container can be reached, and the host for basically the IP address of the container. And now we're going to do this again for the other organization. Now we're going to add an ordering service. Now this is an important part, because the ordering service defines some of the rules that the channel participants need to abide to. So for now, we don't have any specific set of rules that we can that we have to define. So we're just gonna define a standard ordering service and an ordering node to go with it. Yeah, well, this always happens because of my working memory. So okay, now we have the full network set up, and the only thing that needs to be done now, of course, is to actually generate the network. And this is very simple. You only need to click here, and the network is already being generated. Now, the only thing that needs to be done is to select whatever operating system you're on, because, of course, the scripts will vary slightly depending on the operating system. And then you can directly download whatever you have. So far, since there is no cloud deployment, you will be able to download, and this is the only way to obtain the outcome. But later on, it's going to be automated. So basically, you're going to be able to integrate with, I don't know, like Amazon or whatever, to immediately deploy your solution in your own cloud. So here you have all the necessary assets for the network to boot up, plus the scripts. So what I'm going to do is just show you real quick how this all comes to life. So I'm going to invoke the network script with the up argument in some specific folder. Everything that needs to be done is defined in the README. I'm not sure why I didn't get copy pasted, but so it's not like you need to guess whatever needs to happen. It's very well explained. So now what's going to happen is that the scripts are going to set up the network and boot it up on my local machine. It's going to also download what it's doing now. It's downloading some prerequisites. So like you don't have to, of course, there are some prerequisites that you need to handle manually, because we don't want to be too invasive on the customer machine. Like if there is some root permission that you need to have, or some other like very, let's say, invasive change, we just advise to do it, but we don't take control. So what this does here basically now is to first it set up the CAs, then it will ping each CA and obtain, okay, there was something wrong. Lovely. I think something went wrong with the copy paste, to be honest. Yeah. Well, I have a backup, so I'm just gonna do that. Sorry for the inconvenience. I kind of rehearsed it, but whatever. So what the scripts will do basically is just kind of like progressively boot up whatever needs to be booted up. I mean, if I'm taking too long, let me know, because usually like the taking down the network will take a while. But in general, what you will have here as a normal behavior, here it failed because there is some missing file inside for some reason. But what we will do is basically obtain all the certificates and then propagate them where they need to be propagated. And then after that, it will put up the peers and the order, and then basically perform an end-to-end test to make sure that everything is working properly. So unfortunately, something went wrong there, but it should work fine. I tried this before, so it should work. So in general, why would you wanna like why would you wanna go through the, like, in general, the if you do this by hand, which is the basically what you need to compare this with, because there is no assisted tool to help you out in actually bringing up this kind of network, because the technology is very recent. So if you do it by hand, you have to basically change around a couple hundred different files for a complex network, and that's usually about a week of work. And with the platform, you can basically obtain the same network in couple hours of work. So, and in general, what also is useful for a network of this type is to be able to be updated very easily, because that's usually another pain point, because yes, the initial state of the network can be very well defined, but usually if you have more participants, for instance, if I want to include more organizations in the solution, if it's for instance a notarization service, maybe I want to include extra participants, provide the service to extra organizations, and then I'm going to have to change the network, and this is also something that we're gonna offer. So as you see now, everything this time worked fine, and so it just performed an end-to-end test, and the network is launched successfully. You can also see it here in the Docker. You see you have all the containers for the network, and so basically, if I had more time, I will also show you how to play around with the chain code and actually do something a bit more fun. But I don't want to take too much time. It already took too long because of the little hiccup. So thanks a lot for the attention, and I'll just throw the ball back to Jared and then to the guys. There, guys.
Thank you, Damiano. And you know, this is part of what is always exciting about live demos is things always go wrong where they can go wrong, but this is why it's called a garage, and we're here with our tools and tinkering. You know, before I hand it over to Mete, real quick, I just wanted to mention that AstraCode and NetLoom have been working together on something, and I think Jan was going to take 2 minutes to share something about what you two startups have been working on. Am I correct? Is that Jan, or is that Damiano that's going to share that?
Yeah, Jan wanted to. I think Jan will start, and then I can contribute a bit to the discussion.
Okay, 2 minutes. Yep.
We can also do it afterwards, after the last presentation, or now, as whatever works for you.
This is okay. It's still in context of the blockchain stuff. It's probably good now, and then we'll hand it over to Stroma after that.
Okay. Then let me share again. There we go. Okay, that, by the way, is the railway. So you see there's the tracking button here now, so you can actually see the moving trains once it's loaded. There you go. That's actually Amtrak data on a take from their website. It's pretty cool, but it didn't work in the beginning, so I don't want to waste time on something else here than what we planned. So as Jared said, AstraCode and NetLoom we have started to cooperate on something pretty cool, as I think. And we would like to throw it out here. It's a fairly early stage. We just would like to get some feedback, see if anybody would be interested in potentially even bring some value into this. Let me just quickly, I thought we'd do it after this one, so I didn't open it. Give me 1 second. That is, okay. So we call it Project Node D for now. That is just an operational title. As we discussed earlier, right? A lot of IoT and AI projects flat out fail, and a big part of this is trust. And big companies don't really want to share their data with small startups. Analytics companies, startups have problems with sharing their IP for obvious reasons. So a lot stops exactly at that point, because the company might not be willing to pay enough, might not be willing to share actually proper data. So we want to take away that trust issue. And we think blockchain technologies are an amazing tool for doing this, combined with security algorithms. Given the advancements that smart contracts have been making over the last years, you have heard that from Damiano in his presentation. Like, there is a lot been happening, and it's just ever progressing. I think that's something that can't be stopped at this point. A lot of this logic of sharing data, bringing your input in terms of analytics into it, all this can be done in a non-custodial and decentralized way. And that is a service that Astra Code and Netloom, we together are working on. Obviously, this has, by definition, to be outside of the existing entity in a way. It has to be something that can be trusted, so it would have to exist in a decentralized fashion, would have to be a nonprofit and all these things. So it's open for other people to contribute. We obviously, as a business, see a lot of value in this to attract new clients and to bring together startups and big corporates in trying out a few things that they wouldn't have done otherwise. You could also incorporate something like a vested schedule of payment, depending on the actual results of the algorithm that's applied, and then all that controlled by a non-custodial, decentralized algorithm, so nobody can cheat it, right? So this is something we are working on, and as I said, this is by no means anywhere close to being a done thing, but it's something that excites us quite a bit, and it's something where we would love to get some feedback and see if people would be interested in contributing to this. So for that reason, we thought this is the perfect time to just put it out there and get that feedback. And as you see, this is a little bit of a schematic I sketched beforehand, where, for example, Netloom could be part of the data provision, right? For the enterprise client, and there could be a third party in terms of analytics companies or startups that provide their IP without actually exposing it. The enterprise provides their data without actually exposing it. And then you can build applications on top of it, where, for example, Astra Code could play a role. So this is what this is about. I don't want to take too much more time. Damiano, if you want to add something to it.
No, we got to keep moving. Thank you, Jan. But and feel free, I'm going to have the contact information of everyone at the end, and you can connect with Damiano.
And we have the Q&A, so if there's anything.
And yeah, absolutely. And I think this is a good, call to put it out there. And I think we have startups and also corporates that struggle with the same issue of sharing data. So it looks like Mete is ready to go. Go ahead, Mete.
Hello, everyone. This is Mete. I'm the co-founder and CTO of Stroma. I'd like to give a brief explanation of what we do. So at Stroma, we like to specialize in real-time advanced work safety solutions. What that means is we like to build proactive vision-based work safety solutions that can detect anomalies and find if all safety compliance is being monitored. We'd like to build real-time notification solutions, and we actually want to rapidly implement risk mitigation procedures. What that means is we don't want to only detect different anomalies, but we also like to act on it. So what we do is we build a plug and play device. I'm not sure if you can see my camera, but what we have is, you guys see my camera? We have an industrial computer that has a beefy GPU inside. It has various connectivity options, and we also have a camera solution that has 3 different sensors. It has 2 infrared sensors, so it can see in the dark and build a 3D depth image of the scene, and a very high resolution 4K 4K camera that can capture in very high detail. So we can also connect with pre-installed cameras, CCTV cameras, or if there are any other cameras that are already in place. So we have a dashboard that can display all kinds of notification events. So in this case, there was a PPE violation where the worker was within the premises without a helmet. You can see all these notifications coming up from different manufacturing plants. You can see days without accidents. These are KPIs that safety teams track very nearly. So I'd like to focus on the workflows in this case. So I'd like to skip the dashboard. But the main reason we have notifications is we want to give direct feedback to the plant manager if there's anything wrong. Things we do is fatigue and distraction monitoring. So this was the case we did with Unilever, where we detect attention level of the chemical analyst. So we detect all of these points in his face. We build a statistical model of his attention level over time. And if this drops below a certain level, we give a warning for him to take a break so he doesn't mess up when in his analysis. This is a case we have done with E.ON. So these are all field videos that are being sent to our cloud center. So we have a couple of GPUs processing around 10,000 videos every day. So we detect the arc gloves, face shields, and then find if all personnel is compliant to the safety regulations. This is a case we did with together with Siemens and BS. This is a press machine, so this is a video from inside the press machine, and we detect if the worker's hands are in danger, and we can issue warnings and actually stop the machine from coming down and chopping off limbs. We like to focus on 3 different aspects of our business. So we want to have a plug-and-play device, which is extremely easy to install and is compliant with other, safety control systems and industrial machinery. We like to focus on advanced physiological data, so we want to have the utmost advanced safe AI models in our devices, and we want to focus on no video upload to the cloud. So we do almost all processing within these small devices. So with that, I'd like to go to the low-code demo. So I hope everything goes correctly. Let me see. Yeah. So this is the low-code environment where we deploy different algorithms and different control systems. On the left side, you have all of the different functionalities we have already built in. So there are things like WebSockets. We can get data from WebSockets. We can get data from HTTP requests. We can output MQTT requests. We have inputs for S7 Siemens PLC controllers. You can build mainly all logic, code. If anything you want to design in code, you can design with these different functions. We can read and parse CSV, HTML, JSON, and those things. And these are the models we have for our these three models are the current implemented ones for AI. So we have 3D object detection, 3D detection, object detection, and machine safety. Machine safety is the one that detects if people are too close to machines. So we have Stroma XCam, that's the camera that I showed, but you can also connect IP cameras or RTSP streams. In this demo, I'd like to, if everything goes right, I have built a small RTSP server that acts as an IP camera to feed the network. So this is a very rudimentary flow that I've built. So we have the Stroma XCam getting outputting video, and we have 3D detection to build a 3D model. We send this to the machine safety to detect if people are present in the danger zone, and then we send it a notification if we detect someone. In a slightly more complicated version of this, I build a CMOS PLC. So we read the CMOS PLC and find if the machine is coming down or not. So we only do the processing when the machine is working. And then we can also output and trigger an emergency stop if we detect anything. On a slightly more complicated version of this, you can update all of the neural net weights and get and write all of the video feed to the cloud for further processing and incrementing the neural engine. And I'd like to try this out. I hope this doesn't explode, but in a short while you should see the network actually processing images. Yeah, so what we have here is a live feed of sorts that I built a video feed and then outputted this as a RTSP stream. So it's acting as an IP camera, and then we're detecting live all of the people in the scene. And as I said, there are many more different functions we're building. So we have at the moment a very high priority one was Modbus, so we can actually connect with different, serial COM interfaces, output to USB, output to the Ethernet controlled, PLCs and so forth. But yeah, so we're still. So this is a very new. Addition to our tool set, we have been focusing on the hardware and the dashboard, and now we're heavily investing in our low-code environment. And I'd be glad if you have any feedback and yeah, thanks.
Thank you, Mete. I'm going to put the Q&A. We'll answer questions through the Q&A window, so the panelists should be able to see Q&A. But meanwhile, I'm putting the contact information on the screen. And thanks again to all the startups. I think in general, when we look at like how would you do a solution like this in a non-low-code, non-drag and drop way, in most of these would require both a skill set that I think is not necessarily needed when you can drag and drop and maybe not as advanced skill set, but also time and taking in some cases weeks to do something that you can do drag and drop. So that's pretty exciting. So I'll just pause it for a second and see if any questions roll in, and let the if you like, panelists, you can ask questions of each other if you have any questions. That's part of the spirit of the garage, is the interactive experience of the attendees. So let's see if the questions are coming in. Not seeing any questions. One question I had, like we have 2 minutes. I'll start with Mete. Would you expect that, since the difference between using your solution to just monitor and actually stopping a machine, that's a big difference, right? So how would you expect people to use the interface? Like start with just configuring it for monitoring and maybe audit purposes, and then as they get comfortable with that, then they would, you know, connect the actual action of stopping machine or stopping production line, that kind of thing. How do you see that your customers using that?
Exactly. So that's perfectly addressing why it takes so long for us to complete our sales cycle. We literally want to control machinery within our customers' premises. So it is kind of scary to give control of your biggest assets. And so we expect in the future, we expect that people will begin more with monitoring and notification kind of services first. And as time goes on, as we build trust, as we show, the ROI we can deliver, we expect people to connect different PLCs, to connect the different, business, decision making, added into the dashboard. Yeah, I think it will be more of a gradual development.
Yeah.
And
I think if to kind of make this broader with NetLoop and AstroCode, I think one of the important things about these low-code, no-code platforms is if you could start it with some, you keep delivering some basic value like rapid prototyping, but use the same platform to actually use in a production environment. That's super important, right? So the old kind of low code, just doing prototypes and then shifting to needing to something more robust later, is really disruptive. And I think that all of you have something that the customers can start with, something that delivers some immediate value, whether it's a prototype or monitoring, and then move to something like use that same platform to do at scale, and that's important. Well, I think we're out of time. I'll be sharing the recording on the website, and I think we'll probably also have it on our YouTube playlist. So thank you for the attendees, and thanks again to the panelists for sharing what you have, and the contact information is here, and with the recording I'll also share that, so you can connect directly with them or with myself if you have any investors, if you want to ask our opinions on all of these great startups. We're there for you. Thanks, everyone.
Thank you.